Welcome all. My name is Rucha, and I am a machine learning researcher at Haven Studios. So Haven Studios is the first party PlayStation developer studios, and it's based in Montreal. So in Canada, we just have one PlayStation studio, and that's Haven Studios. So I am not directly working on the game, but I am in the R&D team. So we are a group of 7 people who are doing machine learning research on how we can get machine learning and AI, incorporate that into gaming. So let's start. So just to give you a background about the Letta framework. So this is not something that I use for in my 9-to-5 job. It's something that I explored on my own. And I just love the memory-driven architecture, which we're going to talk about. So I hope you get something out of the talk today. And yeah, let's start. Okay, so NVIDIA's CEO Jensen Huang, in his keynote speech at the Consumer Electronics Show in early January, said that 2025 is the year of AI agents. So after he declared this, everybody in the industry started talking about agents. Even you must have heard this term quite recently a lot, right? So what's the hype about AI agents? So I'm going to be talking exactly about that. And then I'll be giving you also an overview of what AI agent frameworks are. Then we'll be talking about this Letta framework and followed by a live demo and a Q&A. All right. So before I tell you what AI agents are, I would just like to know who among you all have worked on or developed AI agents or know about AI agents. Wow, okay. Even if you know anything about AI agents, please raise of hands. Okay, wonderful. And who all are students here? Okay, great. And who's working or having their own, yeah? Okay, perfect. So think of, so we have had an evolution of robots, right? So nowadays we're seeing humanoids. So I've just created this diagram just to show you how the large language models have evolved over the year. So I hope you all have used large language models like Gemini, ChatGPT, yes. Now, chatbot is something which is a fine-tuned LLM. So it's able to engage in domain-specific conversations. So when we go and talk to an Amazon, we go on Amazon and talk to an agent there, it's basically a chatbot. Then came AI agents. So AI agents, they're not just LLMs, but they do something called as planning. They have their own memory and they are able to take actions. So this actions is what we call as tools. So they do something called as tool calling, which is taking actions. All right. So let's begin with the overview of AI agent framework. What is an agent framework? So it's nothing but a software platform that gives you a foundational structure for developing AI agents. And how are these frameworks helpful? So they are pretty much easy to use. Then there's a speed of building that is involved. So you don't have to create from scratch everything because you get pre-built components. You have some certain protocols which differ from framework to framework, of course. And you also get some tools that you can integrate into your AI agents. And then, of course, scalability. So once you have an agent, you can scale them. You can create more agents. You can have them talk to each other. So here are some popular frameworks. And so there's this website called as AI Agents Directory. You can write about it and maybe explore later on if you're interested. And so this website it's great. It's a directory of all the frameworks and AI agents, and it's ever evolving. So they keep on putting in the new agents or frameworks that are coming in every day. So it's evolving every day. All right, so now let's talk about Letta. So Letta, it's based on a research paper called as MemGPT. So the authors of this paper, Charles Specker and Sarah Wooders, they were PhD students at UC Berkeley. And they wrote this paper back in 2023, but they worked on this, and basically MemGPT turned into something called as Letta. And this came out as a stealth startup, and they also got around 10 million funding. So it's AI startup now. All right, so before I move into what Letta is, we need to understand how agents work, basically how their memory gets updated. So let's try to understand that. So whenever I'm talking about agent state, I'm basically saying the agent memory. So we use it interchangeably, okay? So the agent state, it could be empty at beginning. So the LLM, your agent does not know anything, right? But there's something called as LLM context window. So whatever knowledge your agent has, it gets compiled into the context window, which we called as, so this term is called as context compilation. And whenever you're talking to a new agent, any AI agent, you're basically giving them information. So that also gets compiled into the context window. Okay, and then once the agent has this information in the context window, it goes and asks an LLM. So similar to how you talk to ChatGPT, this agent will go and talk to an LLM, right? So the output that we get from an LLM is what we call inference. So now this inference is then passed again to the agent state. So that is how the memory gets updated. And this is what we call the agentic loop. Is that clear? All right, awesome. So here's an example. The user says, hello. The agent thinks, it says, I just got a message. Do I know anything about who sent it? So it does something called as a memory search operation. Okay, so this memory search is basically a tool call, an action that it takes. And then it knows, okay, so this user, her name is Sarah. It replies, hi, Sarah, it's good to see you again. Hope you're having a great birthday. So it also knows that it's Sarah's birthday. But what if the user says, my name is Charles and not Sarah? By the way, all of the visuals, majority of the visuals that I'm using are from this course called as LLMs as Operating Systems. So if you want to explore the course, feel free to do that. It's free on deeplearning.ai. And I'm very thankful for them to have created this course. And they have a lot of different courses, so it's all free out there. Please go and explore. All right, so moving on. So when the user says hello, the agent replies, hi, Sarah. It says, my name is Charles. So now the agent thinks, now it knows that my memory must be faulty. It's time to update the memory. So what it does is a memory update operation. That means the state update operation. And then it replies, sorry, Charles. So now let's talk about Letta's memory-driven architecture. So this paper called as MemGPT, it's based on, so they took inspiration from how operating systems work. So if you are computer science students, you must be knowing that an operating system has something called as physical memory, and then there's something called as virtual memory, which does not exist, but it's like a virtual memory kind of thing. And then we have a disk associated. So basically, they are showing the analogy of physical memory as the context window of an LLM, okay? All right, so whenever I say Letta, I also mean MemGPT. So these two terms are used interchangeably. Basically, what are the key ideas behind? So it has its own self-editing memory, and we'll see how it works. Then it has its own inner thoughts. So the agent is able to think by something called as looping via heartbeats, okay? And also every output is a tool. So basically a tool is an action. So that is what makes a Letta agent autonomous and self-improving. So why Letta? Why did I choose this framework? Well, it has long-term memory. So any of the agents that you create on the framework, they are persistent. So the memory never gets deleted. So if you must have gone and talked to ChatGPT, it does not remember your name. It does not have a memory. So LLMs have frozen memory. But when you're talking about AI agents, their memory is long-term. And a lot of frameworks are model agnostic. Similarly, even Letta is. So what does this term mean? It means that Letta, you can use many different LLMs. So you can choose which LLM the agent can talk to. So you can choose between Anthropic, Gemini, ChatGPT, etc. Okay, OpenAI's models. Then it's open source. So that's a great thing. So you can actually go and read the paper, you can know, so they have a great documentation. And then they also allow integration with external tools. And now, this is my favorite part, the agent development environment. I'll also be showing a demo on this. It's pretty cool and it's very easy to use. You don't need to know a lot of code or coding to do that. All right, so now let's understand how context compilation works. So in a traditional LLM, there's something called as a system prompt and chat history. Okay, so but in Letta, we also have something called as core memory. So it does not only has the system prompt and chat history, but also core memory about the user that the agent is talking to. So it's a special section of the memory. And then the system prompt, it has functions like core memory replace, core memory append. So it has information on how to edit the core memory. And now, for example, here, when the user says, who am I? So now the agent knows that the name is Charles. But then when the user replies, no, the user changed. The user says, no, my name is Sarah. So now the agent again replaces its memory. So basically, the core memory replace action takes place and Sarah gets replaced by Charles. Okay, so this is what is the core memory. So it gives the ability to the agent to learn over time. What happens if agent's chat history runs out of space? So memory is always limited. So there's something called as a recall memory concept in Letta. So what it does is whenever the chat history becomes full, it summarizes and evicts it to its recall memory. Okay. And now, also, we saw that there's core memory, there's chat history. So what happens if core memory becomes full? Even core memory is limited in size. So now Letta has something called as second tier of memory, which is called as archival memory. So whenever the core memory gets full, it again summarizes and evicts it to the archival memory. So an archival memory can be used as a general data source. So you can upload a lot of you can upload your PDFs, handbooks, your personal files to the agent so that it has more data about the user or whatever the user's use case is, right? So yeah, that's all. We have come to the summary. So Letta or MemGPT agents basically have two tiers of memory. And here's a great diagram representing that. So basically tier 1 memory, which is the in-context memory, the core memory or the top level facts that the agent has. And then it has something called as tier 2 memory, which is out of context. So as we saw, archival memory, the chat history when it becomes full, it's the recall memory. So when the chat history becomes full, it evicts it to the recall memory. And when the core memory becomes full, it evicts it to the archival memory. Awesome. So moving on to the live demo. Right now, Letta, they do not have cloud access, but you can go and sign up to get cloud access. Currently, how I have set up the environment is through a Docker container. So this is like a local host kind of URL. So when I go and I sign in, this is how I see the Letta ADE, which is the Agent Development Environment. And you can see that there's a dashboard. Then you can see multiple agents that you have created. You can also give identities to these agents. So let's start by creating a new agent. So I click on this create new agent, and they have also given some starter kits, but we are going to start from scratch. Okay, ladies, have you heard of the term holistic or cyclical fitness? Yeah, where you change your workout schedules and your eating schedules according to your period cycles, and that helps you. So the fitness industry, it's very dominated by males and how they function. But as ladies, if we want to really make a good, to have a balance on our fitness levels and our nutrition, we need to be able to follow a plan which is according to our menstrual cycle. Okay, so I'm going to be creating something called as fitness agent and a nutrition agent. So I think I have created, yeah. So I'm going to be naming it as Mira agent. Okay, so I'll just give you a brief demo of how the screen is. So on the top over here on the left side, you can change the agent's name. Then you can also provide the identities. Then, for example, you can here change the model that you want the agent to talk to. So I'm just going to be selecting the Anthropics 3.5 Sonnet. Then you have access to tools over here. So because I want to make this this particular agent talk to another agent, what I'll do is I'll attach one more tool, which is, so you can also create custom tools, but I'll go to this Letta tools and I'll select this send message to agent async. So just to give you a quick overview of what asynchronous agents are. Just think of how you chat to someone on WhatsApp or iMessage. You send them a message and you don't wait for them to respond you back, okay? So when these two agents are talking asynchronously to each other, they're not waiting for each other to respond back. So whenever an agent says, hi, agent 2, are you there? It immediately, they get a response saying that their message was delivered. And whenever the agent 2 is available, the agent can respond back, okay? So this is what I'm going to be showing you today. Let's go back to our ADE. So I'm just going to be selecting send message to agent async, and on the right you can see attach tool to agent. Tool has been attached. Awesome. So we'll go back, and just to show you, we're not using this today, but you can also attach external tools. Now the tools are attached. We have also something called as data sources. So I'll be showing you this very quickly. And also when you change the model, you can see the context window gets updated. So the size of the context window also changes based on which LLM you are using, okay? Now, the agent has something called as human and persona. So the human is the section of the core memory about the user that the agent is going to talk to. So I have just a few things over here which I have noted down. And so we have someone called as Emma, and I'm just going to be replacing. So Emma, she's age 25, she's a female, her occupation is software engineer. Okay, now this is the Mira agent, which is the fitness agent. So basically, this is the section of the core memory devoted to information about my client Emma. So this is the agent's memory about their client or the user that they are talking to. Okay, so they have what Emma's goals about weight loss is, then her dietary restrictions, her lifestyle, etc. Yeah, and then I have also included how she feels during different phases of her menstrual cycle. So basically, it's always good to give more context to the LLMs, because the more context you give, the better they are able to respond us back, right? Awesome. Now, I'll be also defining the persona of the agent. So I'm just going to be selecting. Okay, here's the persona of Mira agent. So Mira basically means movement, intelligence, and responsive advisor, an AI dedicated to guiding users towards optimized physical wellness. So I'm energetic yet calm, and it's just the persona of how the agent responds to the user. So for example, in dialogues, I reflect thoughtfully. Understanding our body's rhythms can truly unlock our potential, don't you think? Something like this, okay? Does that make sense? Perfect. Okay, and now in the middle, you can see the chat that the user can talk to. So once we have everything like this, and yes, I also have over here in the human memory of the agent, I also say that I also have Emma's historical data of her workouts and fitness levels in the data source named Emma past 6 months data. So just be copying this. I'll just show you briefly what this data looks like. So I just created like a synthetic data of month 1 up to month 6 on how Emma did her workouts. So basically what was her activity type, the frequency of her workouts, then how much time did she devote to her fitness. Okay, so now the agent has more information about Emma. Awesome. So I'm going to be attaching. So over here, you can see tools. I'll go and click the data source. I'll say create a data source and I'll say create a new data source. Okay, so you can rename this data source as Emma's past 6 months data. And then I'll just click and upload the file. Okay, I have uploaded the file and it's there. Okay, so if the user, so I'm acting as Emma, I'll say hi, and you can see here agent is thinking. So hopefully the agent should be able to respond as soon. The agent replies. Okay, that's a lot. I think there's some issue with the network connection, but that's fine, yeah. Hi, Emma. I'm so excited to meet you and begin this wellness journey together. I've reviewed your profile and I love that you're already incorporating diverse activities like strength training and Zumba in your routine. How are you feeling today? So it's very empathetic, right? Yeah. Okay, so I'm just going to be resetting the message history. And so just to duplicate this tab, and I also have this agent called as Nia. So I go and open it. So this Nia agent again, I have given a tool, a new tool, send message. So once I attach the tool, the agents understand that they can talk to other agents in the same environment. Okay, so now Nia is a nutritional intelligence advisor and it's dedicated to crafting personalized nutrition strategies aligned with users' psychological rhythms, lifestyle needs, and holistic health objectives. Now, again, the nutritional agent has information about Emma, her goals, and then there's some information about her. So like the information about Emma only I have and the fitness coach does not, is her dietary patterns, then what she likes eating during different phases of her cycle, etc. So like during your luteal phase, just before your periods, you crave for a lot of sweet and savory food, right? So it has all the information about how Emma eats. So now, just to save some time, I have written down the conversation. So I'm just going to go and grab that from my notes. Okay. Okay. So yeah. So this is the Nia agent and I just type in, hey, just letting you know that I'm going to connect you with another one of my agent buddies. She's fitness coach Meera. Please collaborate to create a synchronized, personalized wellness plan tailored to my needs. And I just say that I think they'll reach out to you directly because I'm going to ask the fitness agent to reach Nia agent, okay? So send. Agent is thinking. And once the agent thinks, it will reply. Okay, again, so many replies. Haha, okay, no problem. So, hi Emma, I'm excited to collaborate with Meera to create a comprehensive wellness plan that aligns with your cycle, fitness goals, and nutritional needs. And yeah. And also just want to let you know that there are like 3 different modes of the chat. So there's a simple mode where you can just see what the agent has replied. There's an interactive mode, so you can see the reasoning behind the agent. And then there's something called as debug mode. So as a developer, you have more control over how these agents work, okay? Right, awesome. So Nia knows that Meera is going to talk to her very soon. Now, okay, so now whenever an agent needs to talk to another agent, the only information that they need, okay, yeah. Yeah, so hey, my other agent friend Nia wants to talk to you. She's a nutritionist agent and her agent ID is. So what we need to do is copy the agent's ID from here. So I just click on copy. It got copied and I'll just paste it here, okay? Awesome. So it got pasted and I said that please collaborate to create a synchronized plan specific, tailored to her needs and also review my 6 months history of wellness. So you tell it that you also have the data you need not necessarily tell it, but it's always good to give more context to the agent. And then I'm specifically saying here that please have a short conversation between you two and then return or come back to me and tell me the plan that you have created. Awesome. Let's do send. The agent is thinking. Okay, so I'm just going to be putting these two on the side so that you know. Okay, so now can you see that there's a send? Okay, that went very fast. Okay, sorry, I think there's some lag, but we'll deal with it. So what's happening here is it's not scrolling too fast. There's definitely a lag. So these agents basically talk to each other and you can see that they're talking to each other. Unfortunately, I'm not able to show you that, but you can see that there's written like send message asynchronous success. Okay, let's see if I'm able to. I think it was better when I had just one screen. So I'll just try to do that. Okay. Okay, this does not happen usually, that it's replying so many times the same thing. That's weird, but it's a startup and they're evolving, so. Okay. Okay, let's get down to the bottom of it and let's see if these two agents have talked to each other and replied to Emma along with the plan. Yeah. Yeah. It says, "Hi Emma, I've just had a great discussion with Nia and we have created a comprehensive cycle synced wellness plan for you. And here's how we'll structure your fitness journey." So it says menstrual cycle days 1 to 5, to gentle yoga, morning stretches, light walking, and also Nia has planned iron-rich anti-inflammatory meals to support your energy. So according to different phases, when in your follicular or ovulatory phase, you do high energy workouts, then you take protein-rich meals, etc. And then I can go and talk to the Nia agent, like, give me the exact plan. What should I eat based on my dietary preferences? So that's how the agents talk to each other. Awesome. So that's all. So just to give you a summary, so what we saw in the live demo was the agent development framework, and it's a visual interface which makes it very easy for developers to create and maintain agents. And all these agents are stateful. That means their memory is, they have their own independent memory and they're persistent in the environment. And also the documentation, it's available on, so if you just go Letta and search Letta documentation, you can find it. Awesome. So let's give 5 minutes to the Q&A. Thank you.